Good morning. Here's 8.7 introduction. Well, before we start, I'm going to give you a riddle, and then when I'm finished, I'll give you the answer to the riddle. So, I don't want this to end. Close this. Don't save. Okay. So, which has less wasted space? A circle in a square or a square in a circle? Now, to answer this question, you have to prove it. So in other words, you have to prove it algebraically using symbols. So which has less wasted space? So here's the wasted space here, the space in the corners. So here's these four corners here. Which area is bigger is another way to answer the question. The area in these four corners here with a circle inside of a square, or the area, these four areas here, square inside of a circle. Now you just can't give me an opinion, you have to prove it. Okay, now with H7, I'm going to start at the beginning because there was at least one student who wasn't here when we started this. Excuse me. So you can skip to this. So this is 8, 7a. So you can skip to, you can just pull the scrubber and across to 8, 7b if you went. And I'm also going to have 8, 7 guided practice A's in here as well. All right, so this is factoring when a is not equal to 1. So we're going to start out with 2x squared plus 5x plus 3. And we're going to say a is 2, the coefficient of the three terms, b is 5, and c is 3. Now the first thing I'm going to do is a times c, which is 2 times 3, which is 6. So I'm looking for factor pairs of 6 that combine to equal 5. So in other words, factor pairs of a times c that combine to equal b. Okay, so I'm going to start out with 6 times 1 is 6, and 6 plus 1 is 7, so I don't want that. And the next thing I can do is 2 times 3 is 6, and 3 plus 2 is 5. So this is the one I want, and these are the two numbers that I want. All right, so what am I going to do with those two numbers? Well, there's two ways to handle this. The first way is I'm going to take 5x and split it up into 3x and 2x. So I'm going to take 2x squared plus 2x, and I'm going to tell you in a minute why I did it this way, plus 3x plus 3. Now the reason why I put the 2x with the 2x squared and the 3x with the 3 is that I'm going to want to factor in pairs. Okay, so I'm going to factor a 2x out of these two terms and a 3 out of the second two terms. So I'm going to have 2x, don't do that. Come on, stop doing that. 2x times x plus 1 plus 3 times x plus 1. Okay, and then I'm going to factor the x plus 1 out of both terms. So I'll have x plus 1 times 2x plus 3. And I'm finished. Okay, now the second way to do this is the cross method. So I'm going to write 2x squared. Now if you don't like this method, skip it. Skip to this and go to the next example or whatever. If you're, on the other hand, if you're intrigued, then stick with me here. So I'm going to draw this cross here. And a times c is going to go here. So here I put the 6. And B goes here, 5. And then I'm going to, you still have to play the game of finding out the two numbers that are factor pairs of 6 that combine to equal 5, but I'm going to put them here, 3 and 2. So then simply write your two parentheses and put x and x plus 3 and plus 2. And then you're going to divide each of these binomials by the leading coefficient. That's the coefficient of the leading term, the term with the highest degree. So I'm going to divide both of these guys by 2. Now 2 goes evenly into the 2 here, so this simply becomes x plus 1. I'm not, here I got this. This is only dividing the second number. Okay. Now 2 does not go evenly into 3, so I'm going to multiply the x by the 2, and I have 2x plus 3. 2x plus 3 times x plus 1, and I'm done. So that kind of skips the whole thing of factoring by pairs, and instead substitutes the division of the second term in each binomial by the leading coefficient of the first term. All right, so that's example 1. Now, let's go to guided practice 1A. Which is 5x squared plus 13x plus 6. Okay, a times b equals 30 and c equals 13. We're looking for factor pairs of 30 that combine to equal 13. Now, you guys are super smart here, so you probably got the answer already, but I'm just going to go through it methodically. 30 times 1 equals 30. 30 plus 1 is 31. 15 times 2 equals 30. 15 plus 2 equals 17. You can see we're getting closer. And then 3 times 10 equals 30. And 10 plus 3 equals 13. Okay? This is the one we want, and here's the two numbers we want. Okay, and so now I'm going to split up 13x into 10x and 3x. So I'll have 5x squared plus 10x plus 3x plus 6. And you can see I've got a 2-to-1 ratio here and a 2-to-1 ratio here, so I can factor these two pairs together pretty easily. Factor out the 5x from both pairs. I got 5x times x plus 2 plus 3 times x plus 2. I now have a common term of x plus 2 in both terms. So I'll have x plus 2 times 5x plus 3. And I'm finished. Now over here, I'll do it with the cross method. So here's my cross. Okay, the 30 goes here and the 13 goes here. And you still have to play the game. This game I played right here, where you find the factor pairs of 30 that combine to equal 13. You put them here. Then you make your parentheses. And you have x plus 10 and x plus 3. And the leading coefficient of the trinomial is 5. That's the coefficient of the term with the highest degree. So divide 10 by 5 and 3 by 5. This doesn't go evenly. It does go evenly here. So you're going to have x plus 2. Doesn't go evenly here, so multiply the x by the 5. 5x plus 3. And you're finished. Okay, that's guided practice 1A. You don't have to do both methods. Just pick one. Or you got a different way of doing it. Do it, but you got to show me your work. GP1. Now, those of you that did this already, you can skip this whole thing and just go on to where we didn't do. And that'd be example 2. So, guided practice 1B. We're going to have 10y squared minus 35y plus 30. Now, you can see there's a common factor here of 5. So we're gonna factor out a 5 out of everything here, and we can't forget that 5 when we write our final answer. So we're going to have 2y squared minus 7y plus 6 in parentheses times 5. Now we're going to put that parenthesis times 5 back in when we're finished. All right, but let's go ahead and factor this thing. Okay, a times b is 12. A times c. So a times c equals 12. And b equals negative 7. Now, the third term is positive, and the middle term is negative. So we're going to have to use the negative factors, two negative factors of 6, in order to get the negative 7. So in other words, we're not going to use 6 and 1 or 3 and 2 or whatever. So we're going to have to use negative 6 and negative 1. So let's start with negative 6 and negative 1. Negative 6 times negative 1 equals negative 7. Negative 6 minus 1, or plus negative 1, equals negative 7. And so this is what we want. And so we're going to split up 7y into negative 6y and negative 1y. And so we're going to have 2y squared minus 6y minus y plus 6. Now, you can, let's see how this is going to work out here. The 2y, and I'm going to have a y. Yeah, that's going to be okay. Now, we're going to have to do something a little tricky here. So let's pay attention to what's going to be going on. First of all, these two terms here, I'm going to factor out the 2y. So I'm going to have 2y times y minus 3. Now this is not going to work out. 2y and 6. Let me stop this for a second. I feel like I made a math error here or something. 2y. Let's see. I got negative 6 and negative 1 and y plus 6. I'm not going to end up with a common term. 1b 2y 7y and 6, 12. Oh, here's my mistake. You probably spotted it already. 8 times b is 12. And so, I don't know what I'm doing over here. This doesn't make any sense. Okay. Should have looked at my notes. All right. So, negative 12 times negative 1, I don't know what I was doing with 6, equals 12. And negative 12 minus 1 is obviously negative 13. Okay, and negative 6 times negative 2 is 12. And negative 6 minus 2 is negative 8. And negative 3 times negative 4 is 12, and negative 4 minus 3 is negative 7, and that's the one we want. So I got to erase the rest of this stuff here. Erase all this here. Okay. Sorry about that. And so we're going to have 2y squared. Now, minus 4y minus 3y plus 6. Okay, now this is looking better. I got a 2 to 1 and a 2 to 1. Okay, so I'm going to factor the 2y out of here. So I'm going to have 2y times y minus 2. Now I'm going to factor a negative 3 out of both of these terms. So I'm going to divide negative 3y by negative 3. So that's going to give me a positive y. So I'm going to put a negative 3 out here. And I'm going to give me a positive y on the inside, because negative 3 times y is now negative 3y. 6 divided by negative 3 is going to be negative 2. Why? Because negative 3 times negative 2 is going to give me 6. Now I've got two terms with a common factor of parenthesis y minus 2. So I got y minus 2 times 2y minus 3. And that's the right answer. You can check it quickly. Minus 4y minus 3y negative 7y. And finally, we have to put the 5 in front to get us back to 10y squared minus 35y plus 30. Now, to use the cross method here, I'm going to put a times c. I'm going to put the 12 here, and here's the negative 7, and here's the negative 4, and the negative 3. And I'll put my two parentheses here. Y minus 4 and y minus 3. And I'm going to divide them by 2, the second number and the coefficient by 2. Get rid of this. And that's going to give me y minus 2 times 2y minus 3. And I put the 5 in front, and I'm finished. Okay, so that's guided practice 1B. Okay. Now, let's go right to guided practice 2B. We really don't need to do much in terms of the example. So let's go to guided practice 2B. Hold on. Let's do guided practice 2A first. Okay. So, guided practice 2A, we don't really need to go through the example. So, GP 2A is 2n squared minus n minus 1. Okay, so A times C equals negative 2 and B equals negative 1. Okay, so we're looking for factor pairs of 2 that combine to equal negative 1. So we're going to use a plus and a minus. So we're going to have, and we want to end up, so we have a negative here and a negative here, so we want to end up with this, the coefficient of the middle term being negative. So I'm going to do negative 2 times positive 1 is negative 2. Okay, and negative 2 plus 1 equals negative 1. So obviously this is what we want to use. And so we're going to do 2n squared minus 2n minus n minus 1. Take the 2n out of here, out of the first two terms. 2n times n minus 1 minus 1 times n. This is plus n. This is negative 2n plus n. So I'm going to factor a negative 1 out of these two terms here. So I'm going to divide n by negative 1, and that's going to give me a positive n. And negative 1 divided by negative n, by negative 1 divided by negative 1 is positive 1. So now I've got two terms. I should have just left it like this. Here we go. All right. So plus, I'm going to make this a plus 1 times n minus 1. All right. So I'll have 2n plus 1 times n minus 1. Okay. Now, that's the answer, and with the keep doing these with the cross method. So here is negative 2, and here is negative 1, and here is negative 2 and positive 1. And you would do x minus 2 and x minus 1 plus 1. and divide this by 2 and this by 2. And this gives you x minus 1 and 2x plus 1. Or n, I'm using x or whatever, but n. Okay. GP2b. All right, so GP2b, 6 is, we already did that one. I substitute that for 1b. This is, let's do, I'm actually going to do GP1b right now, so let's just do that. It doesn't matter what order you do them in. They all pretty much work the same. So we got 6x squared plus 22x minus 8. So we're going to factor a 2 out of everything. So we're going to divide everything by 2 because they all have, all the coefficients are even. So we have 3x squared plus 11x minus 4. The whole thing times 2, and we'll bring that in at the end. Okay, so we're looking for factor pairs. We got a times c is negative 12 and b equals 11. Now the third term's negative, so we're going to have to use a plus and a minus factors for negative 12. We're looking for factor pairs of negative 12 that combined equal 11. So 12 times negative 1 equals negative 12, and 12 minus 1 equals 11. So that's going to work real good. So we're going to split up 11x into 12x and negative x. So we'll have 3x squared plus 12x minus x minus 4. Now notice we have a 4-to-1 ratio here, 12 and 3 and 4 and 1. So this is going to work out okay. So we got 3x times x plus 4. Okay, now I'm going to factor a negative 1 out of both of these terms. Negative x divided by negative 1 equals x. So that's going to become positive. So I have my negative 1 here. So negative x, and then negative 4 divided by negative 1 is positive 4. So it's going to be x plus 4. Now you don't have to have a 1 here. That's unconventional. I just put it there as kind of a placeholder so you can see that I am factoring a negative 1 out of both terms. So now I've got two terms with the common factor of x plus 4. So I'm going to factor out the x plus 4 times 3x minus 1, and I'm finished. And then if we use the cross method, then the negative 12 goes here, and the 11 goes here. And I'm going to have a 12 here and a negative 1 here. And I'll have x plus 12 and x minus 1. And the leading coefficient is 3. So this becomes x plus 4, and then 3x minus 1, since it doesn't go evenly, you multiply x by the number you're dividing by. And remember, we took the 2 out, so we put the 2 back in when we're finished. Okay, now let's go on to example 3. So this, you don't have to put this into your guided practice answers. Okay, so 4x squared minus 3x plus 5. Now, a times c is 20, and b equals negative 3. So we're looking for factor pairs of 20 that are going to combine to equal negative 3. But note that c C is positive, so we have to use two negative factors here. Negative 20, negative 1, negative 10, negative 2, negative 4, negative 5, etc. Well, there's no way that two negative factors of 20 are going to combine to equal negative 3. It's impossible. This trinomial is prime. That is, it cannot be factored. So we call it prime if it can't be factored into two binomials. All right, so we call it prime. Can't be factored. And you just have to kind of look at it and use your common sense and do a little bit of quick mental math, and you can see right away that it can't be factored. And in fact, the vast majority of trinomials can't be factored. Instead, as you know, you have to factor them using the quadratic formula, which we'll get to a little bit later. Okay, so guided practice 3a. All right, so we're going to do 4r squared minus r plus 7. Let's take a look at this. We know that C is positive, so either it is going to be the product of two positive factors or two negative factors, but it can't be a positive and a negative. Now, B is negative, so we know we're going to have to use two negative factors when we're working with A times C. A times C is 28. Well, there's no way that two negative factors of 28 are going to combine to equal negative 1. It's just impossible. Now, if there was a negative and a positive, if this was negative 7, then we'd have something we could work with, because we'd have a negative and positive factors, and maybe we could end up with something, although in this case I don't think it would work. So this trinomial is prime. Can't be factored. Okay, so in other words, we'd have to use 28 times negative 1, or negative 14 times negative 2, or negative 7 times negative 4, and that's it. There are no other ways to factor 28. And there's no way that these two are going to any of these pairs are going to combine to equal negative 1, so it can't be factored. So let's do GP 3b, and let's check this out. So we got, I don't know what happened. How did that happen? So we got 2x squared plus 3x minus 5. Okay, so now we're going to be using a plus and a minus factors, positive and negative factors for A times C. A times C equals negative 10. So we'll be using, we can use a positive and negative factors in order to get a negative number. So, and B equals 3. So now we can probably get to 3 using that difference. So let's look at our factors. Negative 10. We want to use positive 10. We want to end up with a positive number in the middle here. So I'm going to start with the positive number being bigger. Negative 10 times negative 1 is negative 10, and this is 9. And 5 times negative 2 is negative 10, and 5 minus 2 is 3. So here's what we want to use. So we're going to split up 3x into 5x minus 2x. So we got 2x squared plus 5x minus 3x minus 5. Okay, now let's see how this is going to work out here. I got the 5. No, I got 5x and 2x. I knew there was a problem right away. Now I'm going to rearrange these terms because I want to put the 2x squared with the 2x, the negative 2x, and I want to put the positive 5x with the negative 5. So using the commutative property, I'm going to write 2x squared, and I'll make sure you move the signs with the terms. Minus 2x plus 5x minus 5. Okay, and I'm going to factor out a 2x from these two terms. 2x times x minus 1 plus 5, factor 5 out of these two terms, times x minus 1. I now have x minus 1 as a common factor in both terms. So I have x minus 1 times 2x plus 5. And here's the negative 10, and here's the 3, and here's the 5, and the negative 2. And so I have x plus 5 and x minus 2, and I'm going to divide by the leading coefficient, which is 2, and I end up with 2x plus 5 times x minus 1. All right. That's okay. Now, on to, that was example 3. What happened to example 4? Hold on, I gotta pause this for a minute. I lost track of example 4. Okay, so in part 2 here, we're talking about the model for the height of a projectile. And here it is right here. So the height of something, this is just something that's going straight up in the air, equals, well, first we got to get into the bummer here. That's gravity, negative 16t squared. Okay, so that's the force of gravity. That's what's pulling you down from any vertical position is where you start falling. Plus v times t. Now t is seconds. So you can see the longer you fall, the faster you're falling. So that's the bad thing about falling. V is your initial velocity, and t is the number of seconds that you're traveling at that velocity. Now, if there were no gravity, and you threw something at a particular velocity, it would go theoretically forever as long as there's no friction. In fact, there's friction everywhere. Even in outer space, there's friction. So things slow down eventually. All right, and then plus h sub 0, and that's your initial height. So if you're on the ground, then h sub 0 is 0, and if you're standing on a ledge that's 20 feet up in the air, then h sub 0 is 20. Okay, so in the example, they're talking about a cheetah pouncing on an antelope. It's a fun image for you. You know how that's going to turn out. And the cheetah initially jumps up. This is sort of a weird thing to think about because we're using a very uncomplicated equation. But you think of the cheetah as going upwards as 19 feet per second. Actually, it's going outward and everything else. It's much more complicated than this. So, how long is the cheetah in the air if it lands on the antelope's hind quarter 3 feet from the ground? So we're being asked to find t because we're being given all this other stuff. Okay, so let's write out our equation. H equals negative 16 t squared. Remember, we're trying to find t plus initial velocity times t plus h sub 0. Now, h sub 0 equals 0. It's jumping from the ground. V equals 19. And h, where it ends up on the rear end of the poor antelope, is 3. All right, so we're going to plug everything in and then solve for t. So 3 equals negative 16 t squared plus 19t, and h sub 0 is 0, so we just got a plus 0, so we'll just leave it at 0. Now we're going to put it in standard form, which means we're going, like we've done before, we're going to put all the terms on one side and make it equal to 0, factor it, and then use the zero products property. Now I'm going to switch things around. So it would be 0 equals 16t squared plus 19t minus 3. Okay, now a is 16, negative 16, sorry. Now, one of the things we can do to make things easier for ourselves, let's do this. We've got a negative 16 as our leading coefficient, plus 19 minus 3. Why don't we like the fact, we like having the leading coefficient be positive. Now, you don't have to do this, but I recommend it. So let me write the equation like this. Negative 16t squared plus 19t minus 3 equals 0. Let's multiply everything by negative 1. Okay? So we're going to get 16t squared minus 19t plus 3 equals 0. Okay? So now we got 3 times a equals 16, b equals negative 19, and c equals 3. Okay, a times c is 16 times 3, which is 48. Okay? Now, and b equals negative 19. Okay, so we can be methodical with this, and so we're looking for factor pairs of a times c that combined equal negative 19. Now, our factor pairs will be two negative numbers because we want to end up with a negative number in the middle, but 8 times c is positive. So we got negative 48 times negative 1 is negative 48 equals 48, sorry. And negative 48 minus 1 is negative 49. So obviously that's not what we want. And then we'll do negative 48, or negative 24 negative 24 times negative 2 is 48, and negative 24 minus 2 is negative 26. And negative 16 times negative 3 equals 48, and negative 16 minus 3 is negative 19, and that's our magic number. So we're going to use negative 16 and negative 3. So we'll split up negative 19t into negative 16t minus 3t. So this isn't too hard to see how we're going to set this up. So we'll have 16t squared minus 16t minus 3t plus 3. So I take out the 16t, and I get 16t times t minus 1. And I take out the negative 3 from both terms, and I get negative 3 times t minus 1. Negative 16t divided by negative 3 is t, and 3 divided by negative 3 is negative 1. So I've got t minus 1 times 16t minus 3. Now, we're going to have, let's see, so we got t minus 1. T minus 1 equals 0. So we're going to use these with the zero products property. T equals 1. And 16t. So, what does this mean? All right, there's 2 points in time where the animal, the cheetah, is at 3 feet. Okay, it's at 3 feet at 3/16 of a second, and it's at 3 feet at 1 second. So if you think of time on the x-axis and height on the y-axis, and it's going to look like this. That's what the graph is going to look like. And here is 3 feet of height. Then this is 3/16 of a second, and here is 1 second. So my guess is that he will probably reach the cheetah at 1 second rather than 3/16. The common sense would tell us that he jumps here, the cheetah or she, actually I think it's the females that do most of the hunting, males just sit around. Anyhow, probably at 1 second is where the poor antelope meets the cheetah. All right, guided practice number 4. Person throws a ball straight up from a 506-foot building. Okay, the ball's height after t seconds is given by, obviously, h sub 0 is 506, so that's where that comes from. The ball lands on a balcony that's 218 feet above the ground. All right, so how many seconds was it in the air? So we got 218, that's the height. Remember, we're using height equals negative 16t squared, an old gravity bummer, plus v, initial velocity, times t, plus h sub 0. Okay, so the final height we're given is 218 equals negative 16t squared. And how fast is he? Okay, the ball's height plus, oh, he throws it at 48 feet per second, so 48t plus 506. Okay, so we're going to subtract, we're going to put it into standard form, and we're going to factor it, and then we're going to use the zero products property to find the answer. So we're going to subtract 218 from both sides. So we're going to have 0 equals negative 16t squared plus 48t plus, let's see, 8 from 16 is 8. Borrow from the 0, that's 9. 1 from 9 is 8. And we had to borrow from the 5, and so that leaves 288. Now let me double check this. 8 from 8 is 16. 0, yeah, I think that's 288. Hope that's right, because it's going to be a kind of painful to factor this thing. So let's do the same trick we did before, which is let's make 16 positive. Now another way you could do this is simply add 16t squared, subtract 48t, subtract 288 from both sides, and so then you would get 16t squared minus 48t plus 288 minus minus 288 equals 0. Okay, now we're going to be looking for factor pairs. Before I go any further, I'm going to look at my notes on this to make sure I am doing this right, because I already worked it out. 506, 288. All right. Now, okay. Now, we have an opportunity here, and let's see if we can factor out any common factors. Okay? So, obviously, 2 is going to go. It's probably going to go more than once. But let's go for the whole enchilada, because I'm kind of using my common sense here. I know 16 goes into 48 3 times. Maybe it's my lucky day. Maybe 16 goes into negative 288 twice. And wouldn't that be special? Okay, so let's do 288 divided by 16 goes once. 16. Okay. 128. Yes. I know 16 goes into 128 evenly. It goes 8 times. So 16. So I got 16. Okay, and let's divide everything by 16. So we're going to end up with t squared minus 3t minus 18. Okay? Well, all right, you don't have to be, you know, Euclid or whatever, Archimedes or Albert, Isaac Newton to figure out this is going to factor to t minus 6 times t plus 3 with the 16 in front equals 0. Well, the 16 doesn't matter. You divide both sides by 16 and it goes away. So you're going to get t equals 6 or t equals negative 3. And negative 3, obviously, in this particular system, we can't go back in time. So it seems like it was in the air 6 seconds. And let me check that. And 6 seconds is the right answer. All right, so that is the introduction. Now, I realize this has been going on a while, this lecture. I hope you've skipped parts that you already knew how to do. Let's go back to the riddle. Okay, so here we have our square with the circle in the middle. And now remember, you probably can figure it out from using your intuition, but next year you're taking geometry, and so you're going to have to prove this. So here's how you do it. Now, I'm sorry about these terrible drawings. All right, so here, the radius, it's clear that the radius of the circle, or let's call it r, so the area of the circle equals pi r squared. Okay. Now, the area of the square, so this is circle in the square. Well, it's pretty clear that the side is 2 times r, right? R to here, the diameter is r, so that's going to be the side of the square. So the area of the square is going to be 4 r squared. Okay, so we're going to take 4r squared minus 3.14 r squared, and we're going to get about 0.86 r squared is the difference. So that's the wasted space, if you will. Okay, now let's go the other way. The radius, here's r. Okay. Now notice the radius is also the same here and here. Okay, so the radius of the circle, the area of the circle, equals pi r squared. Now, what is the side? Well, let's look at this for a second. This is r, and this is r. So maybe you know if you have an isosceles right triangle, okay, the hypotenuse is going to equal square root of 2 times s. Now, if you don't know that, let's just work it out a little bit, okay? The hypotenuse is going to equal h squared is going to equal side squared plus side squared. A squared plus b squared plus a squared. A squared is going to equal a squared plus b squared equals c squared. So the hypotenuse squared equals 2 times the side squared. You take the square root of h squared is going to equal the square root of 2 sides squared, which is going to equal, so h is going to equal s times the square root of 2. So in this case, the area of the square equals r times the square root of 2 squared. So the area of the square is going to equal 2r squared. So the area of the circle minus the area of the square is going to equal 3.14r squared minus 2r squared, which is 1.14r squared. Therefore, the square in the circle has more wasted space. So this is what you got to, this is what proof is all about. All right, that's enough. The homework, I'll post the homework on Edline. I'll do it right after I finish this thing. So here we go. And it's time to stop.